everyone. Our topic for today is all about some application of the silo theorems. This is the continuation of the discussion of Mr. Buhion and Mrs. Kenyanola. In this theorem, we classify all groups of order PQ where P and Q are distinct primes. Unsa di ay ning distinct primes? Distinct primes are the prime factors of a number that are different from one another. Example for this is 3, 11, 37, 2, and 1. Basta kanang ma-divide ra siya by itself. Okay. Theorem 7.4.11. Let G be a group and PQ be primes with P is greater than Q. If the group of ordered PQ, then G is either cyclic or generated by two elements A and B satisfying the following properties. B raised to P equals A raised to Q equals E, and inverse A, BA equals B raised to R, where P does not divide R minus 1, but P divides R raised to Q minus 1. The second possibility can occur only if Q divides P minus 1. So, natay proof. Proof by Cauchy's theorem. G contains an element B of ordered P. Set P equals the ideal generated by B since P is a silo P subgroup of G. It has 1 plus MP conjugates for some non-negative integer M. Now, 1 plus MP equals index of the subgroup N of P in G, which divides the group of ordered PQ. Since 1 plus MP and P are relatively prime, then 1 plus MP divides Q. However, Q less than P so that M equals to 0. Hence, P is a normal subgroup of G. As above, 1 plus QQ divides P, thus either Q equals 0 or Q divides P minus 1. If Q equals 0, then S is a normal subgroup of G so that G isomorphism P times S. That is G isomorphism Z sub P times Z sub Q isomorphism Z PQ. Suppose Q divides P minus 1, then S is not a normal subgroup of G. However, since P is a normal subgroup of G, inverse A B equals B raised to R for some integer R. We may assume P does not divide R minus 1, else we return to the commutative case. By induction on G, it follows that inverse A B raised to G equals B to the power of R to the power of R to the G. In particular, if G equals Q, we have B equals B to the power of R to the Q, so that P divides R raised to Q minus 1. So, muna ang proof sa Theorem 7.4.11. Next is corollary. Corollary 7.4.12. Let G be a group of ordered PQ. P and Q be primes with P is greater than Q. If Q does not divide P minus 1, then G is a cyclic. In Chapter 5, we define and studied D sub 4, the dihedral group of degree 4. Let us now define the dihedral group Dn of degree n is greater than or equal to 3. Definition 7.4.13. A group G is called a dihedral group of degree n greater than or equal to 3 if G is generated by two elements A, B such that composition of A equals N, B squared equals E, and second is BA equals inverse AB. We denote a dihedral group of degree n greater than or equal to 3 by D sub n. So, Nato example. So mo ni ang example sa dihedral group of degree n. So mana siya sa example 7.4.14. So dili na kay nako tason kay ang time mag-apas ta sa time. Bitaw mana siya. Next is theorem 7.4.15. Let G be a dihedral group of degree n is greater than or equal to 3. Then G has 2 sub n elements. So mana ang theorem 7.4.15. Then next is theorem 7.4.16. Let G be a group and P be an odd prime. If the group of order 2P, then G is either cyclic or dihedral. Now, G contains an element A of order Q. Set S equals the ideal generated by A, then S is a Sylow Q subgroup of G. Hence, the index of the subgroup N of S equals 1 plus KQ for some non-negative integer K. Proof by Cauchy's theorem. G contains an element A of order P and an element B of order 2. Let H equals the ideal generated by A, then H is a normal subgroup of G since the index of the group H in G equals 2. Now, BAB equals BAB inverse is an element of H. Hence, there exists A raised to I is an element of H such that BAB equals A raised to I where 0 is less than or equal to I and less than P. Now, A to the I to the 2 equals the quantity A to the power of I raised to I equals the quantity of BAB raised to I equals BAB inverse raised to I equals BA raised to I B. Again, from BAB equals A raised to I, we find that A equals BA raised to I B. Hence, A equals A to the I to the 2, then this implies that A raised to I to the 2 inverse equals A. Since order of an element A equals P, it follows that P divides I raised to 2 minus 1. Therefore, P divides I minus 1 or P divides I plus 1 since P is a prime. Suppose P divides I minus 1, then I minus 1 equals 0. Then I equals to 1. Thus, BAB equals A, which implies BA equals AB. So, in this case, we find that G contains an element of order 2P and so G is a cyclic group. If P divides I plus 1, then BAB equals A inverse. Hence, G is generated by AB such that the order of an element A equals P and order of an element B equals 2 and BA equals A inverse B. In this case, G is the dihedral group of D sub P. Let us now classify groups of order n is less than 2 or equal to 10. Let G be a group of ordered n or less than or equal to 10. If n equals 1, then G equals the set E and thus is cyclic. If n equals 2, 3, 5, or 7, then G is of prime ordered and hence cyclic. For n equals 4, we know that G is isomorphic to either Z sub 4 or Z sub 2 times Z sub 2. If n equals 6, then G is isomorphic to either Z sub 6 or S sub 3 isomorphism D sub 3. For n equals 8, if G is non-commutative, then G is isomorphic to either D sub 4 or Q sub 8. If G is commutative, then in chapter 9, we will show that G is isomorphic to either Z sub 8, Z sub 4 times Z sub 2, or Z sub 2 times Z sub 2 times Z sub 2. So, kuan ra siya, pwede, kining gi-state diri kanang sa kuan, sa Q sub 8, pwede siya ma-state nga Z sub 8, then pwede po siya ma-state nga Z sub 4 times Z sub 2. Nga naman kay, ang 4 times 2, di ba, equal ka po siya sa 8. Then, pwede po siya nga Z sub 2 times Z sub 2 times Z sub 2 kay, kuan, Z sub 2 times Z sub 2 equals Z sub 4. Then, times Z sub 2, so, makuan ka po siya og Z sub 8. So, let's proceed. Let us now consider the case n equals 9. Then, G has ordered 3 to the power of 2. So, nganong 3 to the power of 2 man siya? Kay 3 times 3 equals 9. Then, ang 3 po, prime number sab siya. Then, since 3 is prime, G is commutative. So, let E is not equal to A as an element of G. Then, the group of an element A equals 3 or 9 if the group of an element A equals 9. Then, G isomorphism Z sub 9. Suppose G has no elements of ordered 9. Then, the group of an element A equals 3. Let H equals the set of A, and A raised to 2. Then, H is a subgroup of G and the group of ordered H equals to 3. Let B as an element G be such that B is not element of H. Let K equals the set of A, B, and B to the power of 2. Now, H and K are normal subgroups of G, and H intersection K equals the set E, and G equals H K. Hence, G equals H times K isomorphism Z sub 3 times Z sub 3. Thus, either G isomorphism Z sub 9 or G isomorphism Z sub 3 times Z sub 3. Suppose now n equals 10. Then, from Theorem 7.4.16, it follows that either Z isomorphism Z sub 10 or G isomorphism D sub 5. Hence, there are up to isomorphism through distinct groups of order 10. We summarize the above discussion in the following table. So, mani siya ang summarize sa atong discussion. Natay order of the group, the number of groups, and groups. So, first is 1. Then, ang number of groups is 1. Then, ayahang groups is the set E equals Z sub 0. Then, second, ikaduha is 2. Then, iyang number of group is 1. Then, iyang group is Z sub 2. Then, next is 3. Then, iyang number of group is 1. Then, iyang group is Z sub 3. Then, other order of the group 4. Then, iyang number of groups 2 dayon. Iyang group is Z sub 4 o Z sub 2 times Z sub 2. Nganong duha man kabuk iyahang number of groups. Kaya ang iyahang groups pwede siya ma Z sub 4 or pwede pod ma Z sub 2 times Z sub 2. So iyahang number of group is duha. So munang duha ang nabutan din ha. Then next is 5. So iyahang number of group is isa. Then iyahang group is Z sub 5 ra siya. Then next is order 6. Iyahang number of group is duha. Kay iyahang group is Z sub 6 or S sub 3. Then next is 7. Then iyahang number of group is 1. Then iyahang group is Z sub 7. Then next is 8. So nasya ang 8, nasya yung number of group nga 5. Yun naman. Kay pwede siya ma Z sub 8. Then, pwede po siya ma Z sub 4 times Z sub 2. Then, pwede po siya ma Z sub 2 times Z sub 2 times Z sub 2. Then, pwede po siya nga ma D sub 4. Then, ang next is Q sub 8. So, munang 5 iyahang groups. Then next is 9. Then na siya number of groups nga duha. Ang group niya is z sub 9, then z sub 3 times z sub 3. Then next is 10. Then number of group niya is 2. Then iyang group is z sub 10 and d sub 5. So mo ni ang table nga gisummarize nato sa ato ang discussion kaganina. So nara ba mo nasabtan guys? Kung wala, pwede ra mo mangutana. Since taas consume na kay tag time, so let's proceed to the next reporter. And that's all for today. Thank you and God bless. Bye-bye. Keep safe everyone.